Williams class. Just to let you know, the videos that you are about to watch today, you were supposed to watch them on Friday, but because of us having the screen-free afternoon, we didn't get the chance to watch them then. So if you're thinking the dates are wrong and everything like that, that is why. Enjoy the video, Williams class. For your arithmetic today, the questions are as follows. 3 times 3. 1,345 plus 3,333. What is today's date as a Roman numeral? What number is next in the sequence? 45, 41, 37, 33. 9 times 7. 64 divided by 4. What is 500 millimeters in centimeters? What is 3,000 meters in kilometers? What is 9:20 p.m. on a 24-hour clock? 54 divided by 6. Here are your answers. 3 times 3 equals 9. 1,345 plus 3,333 equals 4,678. What is today's date as a Roman numeral? V.II.MMXXI. What number is next in the sequence? 45, 41, 37, 33, 29. 9 times 7 equals 63. 64 divided by 4 equals 16. What is 500 millimeters in centimeters? 50 centimeters. What is 3,000 meters in kilometers? 3 kilometers. What is 9:20 p.m. on a 24-hour clock? 9:20 p.m. is known as 21, and then the ... 20. 54 divided by 6 equals 9. So, boys and girls, your learning objective for today's maths lesson is, can I explain fractions that are greater than 1? So, by the end of the lesson today, you will be able to show what happens to a fraction that is greater than 1. So, any fraction that is bigger than 1. Let's have a recap. Use these digit cards to make groups of fractions that are equivalent. How many equivalent fractions can you find? I will give you an example of 2 equivalent fractions that I can find. I would say that 1/3 is equivalent to 2/6. So that is my example of equivalent fractions. Can you make some of your own using those digit cards? Today, we are looking at what happens to a fraction that is greater than a whole. So have a look at this question. We are starting off with this fraction 7/4. So there are how many quarters in the diagram? How many quarters can you see? You have 4 quarters altogether, but how many? Look at the numerator, 7. So there are 7 quarters in the diagram. How many quarters make one whole? Now, to make one whole, you have to have the same number as the denominator and as the numerator. So if the denominator is 4, then the numerator must also be 4. And the reason why you need that to happen is because this fraction sign, this line here, is also, it also means divide. So if you have 4/4, that's the same as 4 divided by 4. And what's 4 divided by 4? It's 1. So that's why it has to be 4/4. And that's why it's equal to 1, because 4 divided by 4 equals 1. So 4 quarters make one whole. So 7 quarters then, because we know we have 7 quarters all together, we're starting off with 7 quarters, equals 1 whole. And then to work out how much is left over, remember your division methods. There's when you're working out a remainder. If you've got 7 altogether, I've already taken out 4. How many is left over? How much do I need to add to 4 to get to 7? 3. So 7 quarters is 1 whole and 3 quarters. So because you've put 4 here, remember these two need to add up to equal 7. So that means that if 4 is on that side, 3 must be on this side. So the two fractions you have are 4/4 and 3/4. And when you add them together, add the top numbers together, add the bottom fractions, add the bottom numbers together, you get 7/4, which is the number or the fraction that we start with. How would you split up this fraction so that it becomes some wholes and a part? How I would like for you to do this is to first count how many parts have been shaded in. Let's do that together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 have been shaded in. So if 13 have been shaded in, then I'm going to write that as my top number, my numerator. And then what I want you to look at is just one bar and count how many squares are in one bar. 1, 2, 3, 4, 5. There you go. So how would you split this to make sure that there are some whole and some parts? Off you go, figure that out for me. So the way that I would write this as a fraction is I know that there are 13 shaded all together. Then I want to see how I would split this in order to work out what my denominator is. So I would split it by looking at the wholes. So how many parts have I shaded in that are whole? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, these two equal 10 and they've been shaded in completely. So that is going to be my denominator because you've got the wholes. I'm not going to count what's left over. The ones that are left over will be counted up later. So that is the fraction that I am working with. And the way that I would divide this so that there are some whole and a part would be to look at the denominator, and that is going to be the same in both cases. Now, what did I say about making a whole? I mentioned before that in order to make a whole, the bottom fraction has to be the bottom number, the denominator has to be the exact same as the numerator. So the denominator is 10, that means the numerator will be 10. Now, I've already now taken 10 out of my 13 and I've put it in the left-hand side circle. So what do I have to put here? I have to put here the number that you add onto 10 in order to get 13. And that would be 3. So that's how you would divide it. And to test that it's working, try adding them together. 10 plus 3, and then you do 10 plus 10. And when you add fractions, the denominator never changes when they're the exact same. So that stays as 10. But you add the numerators together, 10 plus 3, 13. So you end up with the fraction that we have when we first started with this question. So this will explain it for you in more detail. And it's just another example to help your understanding of this concept. It says here to complete part-whole models to answer these questions. Now, the first one is 9/5, and it's asking you what are 9/5 the same as. So if I just take that away, that is 9/5 because out of, you've got 9 shaded all together, so that's your numerator. And then you look at how many wholes you have, and you have one bar that's been shaded in whole, and how many parts are in that bar? 1, 2, 3, 4, 5. So 5 is your denominator. This is the same as saying 5 out of 5, because 5 divided by 5 does equal 1, so that's a whole. And then what's left over? Always look at the numerator. You've put 5 in this circle. What do you need to put in this circle? In this circle, you need to put a number that you add to 5 to get 9. And that would be 4 out of 5. B, how many quarters are the same as 2 wholes and a quarter? So you count up how many have been shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is going to be your numerator, as you can see. And then how many parts make up one whole? And one whole is a bar that's been completely shaded in. And how many parts do you need to shade in to make one whole? You need 4, because that bar is split into 4 parts. So your denominator will be 4. Now, the way in which you split this is you see how many holes you've got and you count them up. So here you can see that we've shaded in whole 2 bars. So count up how many parts make those 2 bars. That would be 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 over 4. Now, the reason why 8 over 4 is not the same as 1, but it's the same as 2, is because, remember, I said, is because 8 over 4, 8 quarters, however you want to say it, is the same as saying that we are doing 8 divided by 4. And what's 8 divided by 4? 2. It's not 1, it would be 2, which is why instead of creating 1 whole, you've created 2 holes. And then what's left over? We've got 9 in the big circle, our answer circle, and then we've put 8 in one of them. What do we need to put in the other one in order to then complete this part whole model? We need to put the number that would add to give you 9, which would be, are you saying this out loud right now? That would be 1. And the denominator never changes. So if it's 4 in the main section, and it's the denominator that doesn't change. So you keep the denominator the same every time. If you can see here, the denominator here is always over 5, and the denominator here is 4. So that doesn't change. Now have a go at doing these yourself. You have got a part whole model that has been partly done. You're going to draw this and you're going to write sentences to describe what the fraction 14/6, which is this one, 14 over 6, is equivalent to. Off you go. This question. Jessica says, it is impossible for me to have more than 4 quarters of pizza, and a quarter is a pizza split into 4, which I think is true. Let me try and draw it for you to show you. Here. So a pizza, if it's split into quarters, that means it is split into 4. Really badly, but that is 4 for you. Shall I see if I can draw that better, actually? Because that was not great. Circle here, and then 1 line going down and 1 line going across. So do you agree with Jessica? You have to explain your answer. If you don't have a partner, then you can explain it to a family member, a sibling, mum, dad, or just to yourself. Sketch a picture to help you explain what you mean. So you should have a picture of 2 circles and they've both been split into 4 parts. Jessica's told you it's impossible for me to have more than 4 quarters of pizza, as a quarter is split into 4. And 4 quarters of a pizza means 4 out of 4. So in the end, you should have 2 that have been split into 4 slices. Your independent work. You are going to have a go at answering these 4 questions. Off you go. Here are your answers. Complete the sentences. There are 7/5 altogether. 7/5 is equal to 1 whole and 2/5. Question number 2. Shade the bar models to represent the fractions. The fraction you are representing is 5/3. So the way in which you would complete it is by shading in 5 of those parts. 5 over 3, or 5/3, is the same as saying 1 whole and 2/3. And that can be written in this way. It can be written with the 1 being big and then the fraction of the remainder written next to it. Question number 3. Complete the statements. A. 12 halves is equal to 6 wholes. B. 12 quarters is equal to 3 wholes. C. 15 over 4 is equal to 3 wholes and 3 quarters. D. 15 over 2 is equal to 7 wholes and 1/2. Question number 4. Whitney bakes 26 muffins. Muffins are packed in boxes of 4. How many boxes can Whitney fill? And if you figured out or worked out or calculated that Whitney can fill 6 boxes, then you are absolutely correct. Very well done. That is all for our maths lesson for today, Williams class. I hope you are staying safe. I hope you're staying well, and I will see you very, very soon.